Okay, fine, yes, it's a sad day, right? We are mourning the loss of my beard, right? Sorry, right? It's warmer. It's what happens. All right, so today, as revenge for making fun of my beard already, we are going to learn a really tricky skill, but when you have this down, you will be able to ace it. Again, this looks tricky, it has several steps, but when you get it down, and you will, you can do absolutely perfect at this. So don't be worried. So here's what we're doing. We are now ready for the ultimate payoff of all the other work we were doing. We now have learned SL. We can translate English into it. We can solve the truth value of sentences. And now we can use it to test the validity of arguments. Good. So we would first translate the argument into SL and then, right? So what we have to do right away is we have to review the idea of validity. We will be using these truth tables to test validity. We've talked about validity before, but now we need to make sure we know how to apply the concept. So let's start with our most basic definition of validity, right? So the most basic definition was the conclusion follows necessarily from the premises, right? That's the idea. Keyword necessarily. Remember we were looking at such as Venn diagrams for the Britney Spears argument, and we said, well, she might suck, she might not. Well, that's not how validity works. Validity has to be necessarily following. It not just might follow. And then we developed the more technical definition, which is this one. If the premises are true, the conclusion has to be true. But notice again, look what I've underlined. The key is has to be. If the premises are true, the conclusion can't be false. If they could possibly be false, then it's not valid. A valid argument has to be perfect. And then lastly, we have our definition of invalid. This is the definition we will be using for these truth tables. This is the key idea. It is possible, if an argument's invalid, for all the premises to be true with a false conclusion. This is how we have to work with validity to test an argument. We can't find anything out about an argument if the premises and conclusion just happen to be true. They have to have a necessary connection. So let me look at a very corny argument to show this to you. That's right. So here is my very corny argument. Look at it. It says premise, right? So let me scroll down so we're only looking at our invalid case of argument. Good. Here is our goofy little argument to make a point about why we test logic this way. Premise 1. These videos appear on our logic course website. Premise 2. These videos contain teaching about logic. Therefore, the instructor in these videos is my teacher. Now, all of those things are true. You could see the start of a possible deductive argument, but we can see that these don't follow. But how do you test it? To test it, you couldn't simply say, well, let's see, are the premises true and is the conclusion true? That doesn't reveal the logic because these things all happen to be true. So the only way to test the logic is to see, is it possible to prove this invalid? Is it possible that these premises could be true and this conclusion could still be false? Because if that's possible, then, as we see right here, that's how you determine if it's invalid. So we are actually trying to prove arguments invalid. If we fail, they're valid. So look at this. All we have to do is find a situation in which it's possible for the premises to be true and the conclusion to be false. So let's find a situation. These videos appear on our logic course website. Yes, they do. These videos contain teaching about logic. Yes, they do. All we have to do is it possible that the instructor in these videos is not my teacher? Can that conclusion be false? Sure it can. Hi! I am your instructor. Now, again, I am so sorry. You see, that conclusion didn't necessarily follow because I could easily replace this instructor with another one that's not your teacher. That's how you reveal the faulty logic, showing that the premises can be true and the conclusion could still possibly be false. All right. So now, we do need a little bit of a pep talk, right? So, you are not doing this in these videos, but you must. This is very important. You must repeat after me. We are negative, cynical, and pessimistic. Repeat. We are negative, cynical, and pessimistic. We want all arguments to be invalid. Repeat. We want all arguments to be invalid. And so, we want true premises with a false conclusion. Repeat. We want true premises with a false conclusion. Don't lose focus on that. Your goal is always a negative goal when you're doing this work. You are trying to prove these invalid. If you fail, they're valid. So invalid is what we want. We hate people's arguments. We want to defeat all of them. We want to achieve true premises with a false conclusion. We are trying to do that. That's what we're trying to find. That's all we're looking for. Now, of course, if we can't find it, we lose, the argument wins, the argument's valid, but that's not what we want. We want the argument to be invalid, so that's our goal. All right, so here will be our strategy, right? Look, it has a number of steps. Good. So what we will do first, right, make sure you understand these steps, and I'll keep repeating them over and over, right? And so we will first begin by writing an argument out on a single line, right? I will show you how to do that. Then we will do our usual thing. We label our main connectives. Those are the values we care about. Those are the final values we'll be looking at. Now step 3. Let me look at step 3 for a bit and explain it. Remember, and if you don't remember, go back and look at the beginning of the, the SL truth value video. And I went through this algorithm of how to fill in a truth table. Well, notice, how many sentences you have in your argument will determine how many different truth possibilities there are, and as you saw, that those increase exponentially. So here's an easy way to remember it, right? If you have 2 sentence letters, you're going to need 4 rows of possibilities, 4 rows of possible truth combinations. If you have 3 sentence letters, 8 rows, 4 sentences, 16 rows. And if you're a math nerd, you can simply use 2 to the n, and n represents the number of different sentence letters, right? How many different letters do you have? That'll give you different truth combinations. Then, and this is what the algorithm was doing, step 4, fill in all possible values. We'll do this again and again as we practice, but remember, we start with the sentence letter that's last alphabetically, and that fills in going down each column under the sentence letter, true, false, true, false, true, false, true, false, all the way down, start to from beginning to end in your table. As you move up the alphabet, you double how you alternate. So the next letter alphabetically moving up would be true, true, false, false, true, true, false, false, and so on. And step 5 is something we already saw when we looked at the S exercises, solve from the smallest to largest scope for each statement. And step 6, circle the final values under the main connectives. We already did this, but you'll do it in your table for each premise and the conclusion. So for each premise, you'll have a final circled value under the main connective. And now, review. At the end of producing this truth table, we are looking for validity and invalidity. But remember, what we are looking for specifically is an invalid instance. We are looking for any line of our truth table, any possible situation, any world that could occur where the premises are true and the conclusion is false under the main connective. If we don't find that, if we don't succeed in proving the argument invalid, then the argument is valid. Got it? Okay. So please write these down on a sheet. Please pause, right? You can abbreviate them, right? I will in a second, but please have these written down somewhere clearly. This is what you want beside you as you're working. And in fact, let me make your notes really all in one. I would also add your truth conditions for each of your connectives to this page. I would have this page right here, right? Write this down in simple form. These are the steps you'll use on the final exam. And of course, while you're doing this work together with me, Good. Make sure you have this. All right, so I am going to quickly go through and shorten our instructions, right? So we have it in a nice short form, but of course, good. But of course, you can always refer back to the fuller line. Remember, go back if you didn't do it, pause the video, make sure you have all those rules. Good? All right. So here is our simplified version of our strategy, right? If this is what you want to take notes on, that would be great. That would be a good version. All right, so let's look at our first example. Our first example is taken from the examples on pages 9 and 10. This is that argument that talked about the grass being wet and therefore it's raining. So all I have done is converted that argument here at the top of the page into SL. And what do? Step 1. We take our argument, write it out on a single line, clearly separating the premises. Look at, I've drawn dark lines to separate the premises, and then very clearly separating the conclusion. Step 2. Now we label our main connectives. Good. So you will draw stars over them or something. Sorry, they don't all show up really cleanly here. I will bold my main connectives. Notice, this third premise is simply the sentence W. Well, so that sentence is its own main connective. Same thing with the conclusion. So I bold those letters. When I've filled in those letter values, those will be the main connective values. So those will be easy. Now I need to determine how many different truth possibilities there are because, remember, to test for validity, we're looking for necessity. We need to look at every possibility before we can be sure it's valid or invalid. So I need to look at, now remember the algorithm I showed you when we were looking at truth values of sentences. So, and again, we can look up at our rules, right? What did our rules say, right? We determine the number of rows you'll need, and I gave you that little chart. Or we could use 2 to the n. Well, I know. I count up my number of sentence letters. How many different ones are there? There are 2. So I know I am going to need 4 lines in my table. I'm going to need 4 different truth possibilities. So I'm assuming you have lined paper, so this is easier for you to draw. And so you will simply just mark out, right, these 4 lines. Good. You will simply draw out your table and then draw a border around it so you know that you only have to work with 4 lines. Now I fill in all possible combinations of truth values under the letters and I follow my little algorithm. I start with the last letter alphabetically, and this letter will alternate true, false all the way down the table. Wherever W appears, it will alternate true, false, start to finish. It'll always start with true, it'll always end with false. Just be careful of your sequencing. Then I move up the alphabet and I double how I alternate. So R's will alternate every 2 lines. Wherever R appears, alternate every 2 lines. True, true, false, false, true, true, false, false, until you're all the way down the table. Keep doing that for all of them. Just be careful that you stay in your sequence. So now I have all the different truth possibilities that are possible. Now I need to solve from smallest to largest scope. I will start in the first premise. In the first premise, the smallest scope, of course, is the sentence letters. That's why I filled those in first. And now, notice, this negation only applies to R. So it has the next largest scope as I'm working my way up. What does a negation do? A negation simply reverses the truth value of the sentence. So what do? Simply reverse the truth values of R going down. Now, this technique, because underlining doesn't show up so much, what I actually do when I'm working is draw a line under and over this column so that it stands out visually. And that makes it easier to grade, by the way. I can see the order you're working in. But let's do the cross-out method today. I think this shows up the easiest on the computer. So what I'll do is, notice, these values under the negation have replaced the values under R, so I don't need these anymore. So what I'll do is I'll just darken them in so we can barely see them. right? They're still there, right? So when you cross out, make sure you can still see what's under your cross out in case you need to check your work. But now it's clear that these are the only two values left in this first premise. So now I can compare them in terms of OR. So look, we need to know our truth conditions for each connective, and we need to keep repeating this, saying it out loud like a crazy person to your computer, to your phone, or to your tablet, whatever you're working on. An OR has what conditions? An OR is only false when both sides are false. Notice, because we've memorized the exception case, it makes it easy to look at our table because we won't have to go one line at a time. We'll just look for the false case. So we're looking for the case where both sides are false, and that will be the false cases. What do we have? None. There is not a single case in this premise where this disjunction where the OR is false. So all of the values under the main connective are true. Now, what I'll do this time to make this stand out is whenever I have my main connective value, I'll highlight it in orange, right? So you can see it clearly. There it is. First premise is done. That's the value under the main connective. Second premise. Look at the only value left is the main connective value. Please make sure you have this highlighted in some way. Put a star over it. So this is the only value we need to solve. And we have a conditional. What are the truth conditions for a conditional? A conditional is only false when ordered true then false. Repeat after me. A conditional is only false when ordered true then false. So notice, we will just scan our columns and look for a false case. I see it right there in line 2. That is the only case that's ordered true then false. What does that mean? All the other cases will be true. This is the value under my main connective, so I will label it. There it is, orange. That value is all I care about for that second premise. The third premise, notice, is already solved, right? I already have my final values. There they are. Also for the conclusion, already solved. Those are the final values under the main connective. So now we're ready to read. We have circled the values under each of our 3 main connectives for our premises. We have circled the main connective value under the conclusion. Now, what are we looking for? Remember, we are negative, cynical, and pessimistic. We hate arguments. We want to disprove all of them. We want them invalid. So all we care about is finding a situation that has true premises with a false conclusion. That would prove it invalid if you find such a case. What do we find? Look at line 3. Row 3 proves this argument sucks, right? So I'm going to label out line 3 for Jeff, my grader. Look, Jeff, line 3 has, and I'm being very careful that these are the main connectives, true premises, false conclusion, I win. What does winning mean? I prove this argument invalid. You suck, you stupid argument. I win. I found a case with true premises and a false conclusion. All right, so for our next example, all I've done is taken the argument again from pages 9 and 10 of the syllabus, right, that we looked at before. What is this? This is our Snarfblatt Little Mermaid argument. Good. So I've taken the argument, step 1, wrote it out on a single line. Let me make sure I've done it correctly. Yes, good. I have separated the premise, clearly separated the conclusion. Now I go through and label my main connectives. Sorry, this one won't really do much, right? These conditionals don't really bold very well on this computer, but you would clearly mark these out, right? For you, these are our main connectives for the premises and conclusion. Then I determine the number of rows by counting up the number of different sentence letters. In this case, we have 3 letters. What does that mean? We are going to need to look at 8 possible truth combinations, right? So I'll label those out before I begin. Good. Let's get rid of the rows we don't need. Good. So you would, on your line paper, mark out 8 lines and then clearly draw borders around your table to make it easy to work in. Then we need to fill in all our possible sentence letter values. Notice, no matter what order it's in, we still fill in the same combination going up the alphabet. So, starting with W, I alternate W's, true, false, every line all the way down the table Doesn't matter how many columns, how many rows I have. I just keep filling in. In this case, we have 8. I keep working down my table, right? Following the same sequence. True, false, oops, all the way down. Good. And then I work up my alphabet, right? So I work up. When I get to T, I alternate every 2 lines, right? Try to get into the zen of filling these out, right? Good. Wherever the next letter occurs, I alternate in the same sequence because each of these letters match up in their truth values across these lines. So when I get to S, now I alternate every 4 lines. I keep doubling how I alternate. Good. So S every 4 lines wherever S occurs. Now I have all my different truth combinations following my little algorithm so I don't have to overthink. Good. So double check. Last letter alternates every line. Second to last letter alternates every 2 lines. Third letter working up. First letter alphabetically alternates every 4 lines. Good. Now I'm ready to solve for my main connectives. I work from smallest to largest scope. All of these are all ready to simply solve the main connective. And so I have a series of conditionals. So let's work. But we have to remember how that works. What is the truth functions of a conditional? Please say this out loud. It really helps. A conditional is only false when ordered true then false. So look how easy this is. Now we simply scan through our columns under this conditional and look for the false cases, right? I see one in line 2 and in line 4, right? Those are the only ones that are ordered true then false. And so what does that mean? All the other cases are true. So I can fill those in really cursorily. That is the main connective, right? So I will circle that on the computer. I'll label it in orange. Good. We're ready for the second premise. Second premise, again, a conditional. A conditional is only false when ordered true then false. I see those cases straight away, right? I see 2 cases. Let me double check. Yep, only lines 3 and 7. What does that mean? All the other cases are not ordered true then false, so all the other cases, are true. Easy to fill in. That is my main connective, so I circle it. I use my orange to represent, to highlight the main connective. I am now ready for the conclusion. What are we looking for? Again, it's a conditional, so I'm looking for the cases that are false. Repeat. A conditional is only false when ordered true then false. I only see 2 such cases, lines 3 and 4. All the other cases will be true. Good. That is my main connective under my conclusion, so I circle that as well. Good. Now I have my main connectives labeled in my premises and in my conclusion. Now I need to re-invoke my mantra. I am a negative, cynical, and pessimistic person. I want to disprove arguments. I want them invalid. What do I need? I want to find a situation where the premises are true and the conclusion's false. So let's look it over. Damn. This stupid argument, right? What did we find? There is no invalid case, right? We could not find what we were looking for. We were incredibly angry. We wanted this to be invalid, but it's not. There was no row where the premises were true with a false conclusion, so we lost. This is so sad, right? Sad face. It's valid. We couldn't defeat the argument. All right, so what you need to do right here is now pause the video and go and try the T examples on your own. If you can work them very well, looking through your little 7-step method, right, being very careful, then keep going, right? If you can do a few of these before you unpause this video and continue, that's great. But if you want to go one at a time, right, try the first example on the T exercises with a full truth table. Try it on your own, come back to the video. But of course, if you get stuck, if they get too hard, then please just follow along with the video as you practice the skill. But anywhere where you can pause the video and work ahead of me, that would be great, right? So that you're getting more autonomy, more confident in this skill. All right, so you are now pausing the video to try the T exercises on page 20. All right. So let's check your work. I have taken the first argument. Now, what is the actual first argument on page 20? It's actually the Britney Spears argument from pages 9 and 10. Remember? There we are. So I take the argument from page 20, exercise T number 1, and I wrote it out on a single line on my piece of paper, right? I'm assuming you have lined paper. Separated the premises, clearly separated the conclusion, right? I could have made that darker. Now what are we doing? Now we need to label our main connectives, right? Remember, this one won't show up much, sorry, but let's at least bold these main connectives here. Notice these negations are the largest connective of my second premise and conclusion, so those are my main connectives. Now I determine the number of rows. There are only 2 sentence letters, so I will only need 4 rows in my table. I will not need all these other rows. Sorry, let me just get rid of those really quickly. Good. So, what do? We now need to fill in all possible values under our sentence letters. So, we go alphabetically to S. We know how this works. S will alternate every line all the way down the table. Wherever S appears, it will have the same values. They must be consistent. We work our way up the alphabet, so B alternates every 2 lines. Wherever B appears, it alternates in the same sequence. So we have every truth possibility. Now I will go to my first premise. I solve from smallest to largest scope. What do we have? Simply the main connective left, the conditional. We are simply looking for the exception case using our little motto. A conditional is only false when ordered true then false. I see such a case in line 2. All the other cases will be true. Second premise, I simply have a negation to solve. It's my main connective. What do? Simply reverse the values of my sentence. Oops, sorry, forgive me. I forgot to circle, right, or my orange, my main connective of my first premise. I have finished my main connective of my second premise and simply need to reverse the values for my conclusion. Easy to do, simply reverse the values, and I circle that value as well, so I am only looking at the values under the main connectives. What did I find? I want this to be invalid. When is it invalid? When there are true premises and a false conclusion. Yes, I win. We found this Britney Spears argument clearly invalid, and we don't have to use our goofy Venn diagrams or imagine a situation method. We proved it specifically, very precisely. What did we find? This argument loses. We found true premises and a false conclusion in row 3, so we win. All right, so remember, you're trying these on your own, pausing the video, going as far as you can, and then coming back to check your work. Now, I do recommend that if you are making a mistake, don't just correct your work. Do it again with me. If you find yourself making mistakes, you need the practice of all the organization. So, next example, T exercises number 2. What is this? This is simply the Doug is drunk stumbling around argument that we saw in 9 and 10. What do? We first write out our argument in a single line, clearly separating your premises, clearly separating your conclusion. We label our main connectives. Remember, sorry, this won't really bold on my computer, but you can do it. What do we know? Since this sentence letter is its own premise, then the letter is the main connective. So we label it. I would, again, draw a little star over it if I'm working on pencil and paper, which you should be doing. Please pencil, right? Now, I need to determine how many rows I will need. There are only 2 different sentence letters, so I will only need 4 lines. I do not need these additional lines, so I will erase them, get them out of the way. you will clearly draw a border around your table so you know how to work. Then, I need to fill in the basic sentence letter values. I start, as we know, at the last letter alphabetically. What does this do? Alternates true, false, all the way down, right? So I fill in S the same way consistently. I double my alternating as I work up the alphabet. So D alternates every 2 lines. Clear. My values are filled in. Good. Now I am simply trying to solve from smallest to largest scope to determine the values under my main connectives. We have a conditional, again, very common in logical arguments to have conditionals. We are looking for the false case. A conditional is only false when ordered true then false. There is what I'm looking for. That case will be false. All the other cases are true. They are not ordered true then false, so they are true. That is my main connective. I circle it, draw it in orange. Second premise, that is the final value under the main connective, so I circle that. Same thing with the conclusion, that is the final value, I circle that. What did I find? I am looking for a case that has true premises and a false conclusion, and again, like we found, right, we did find what we're looking for. This argument is invalid. We win. The argument stinks. We clearly label it. We celebrate that we defeated another argument. We rule. Now, increasing complexity. We now have the NASCAR mullet tank top argument from pages 9 and 10. So I've written it out on a single line. I am carefully labeling my main connectives. Sorry, that one doesn't really show up when I bold it, right? Here are my main connectives for my premises, for my conclusion. There they are. Now I determine my number of rows. Because I have 3 letters, M, N, and T, I will need 8 lines in my table. So I fill those in. I get rid of the columns I don't need. On paper, you will clearly mark out the rows you need. Good. Now it's the same process. I work under my sentence letter values. I fill in all the values using my algorithmic method. I go to the letter last alphabetical, which in this case will be T, and this one alternates true, false every line as I go down. Wherever T occurs, same thing. Good. Then I work up my alphabet. Be careful with your alphabet. It's tricky for me, right? I go to N, right? This letter will now alternate every 2 lines. So I fill that in all the way down. Every N must be the same, right? Must alternate true, false, wherever it appears. Then I work my way up the alphabet to M. M will alternate every 4 lines. Clear. Wherever M appears, it will alternate every 4 lines. I double how I alternate as I work up the alphabet. Now, let's solve. We're solving for the main connective. We have to go from smallest to largest scope. What is the smallest scope? Inside the parentheses. So I start with this or here, okay? So let's look. An or is only false when both sides are false. So we simply look for the cases where both sides are false. Those are the only false cases. That makes it very easy to solve. All the other cases are true. That is my main, be careful. That is a larger connective, so notice what I will do. I will cross these out. I don't want to pay attention to them, so I'm going to cross them out. I can still read them, right? But I want to make sure I am not looking at the wrong thing. Good. So, sorry, had a little computer glitch there. I was in the wrong column. All right, so, damn it. Sorry. Good. Okay, let me fix it. See, we all make mistakes. Good? All right, now it's clear. So what I have done is crossed out the columns that I no longer need. The values of M and T have been replaced. I know I only need the value under that or. That value replaced all the other values inside these parentheses. So now I can clearly see that I'm only looking at those two columns. I am comparing the column under N, right? So me, if I'm working on paper, I would draw a little underline, right? So I can clearly see what I'm working on, label this out, so I'm only looking at the right places. If you want to draw a line through these, like I've graded them out, that's nice. So I'm comparing the column under N to the column under OR in terms of the main connective, the conditional. A conditional is only false when ordered true then false. I only see one such case. Let me double check. Yep, that's right. That's the only false case, line 6. What does that mean? All the other conditional values will be true. So I can fill those in very easily. That is my main connective. So I want that to stand out, right? So I will circle it, in my case, label it in orange. The second premise is N by itself. So that is the main connective. So I will highlight that. Good. The third premise, the main connective needs to be solved first. It is the negation. What does a negation do? Simply reverses the truth values of the sentence to its right. So those are the values. I will circle those, in my case orange. Those are the final values for the third premise. Conclusion is already solved for me. Those are the values itself. I highlight those as well. I circle them, my case orange. Now, I need to see if I can make this argument invalid. We want it invalid. We want true premises with a false conclusion. Did I find it? Let me look, right? I'm looking really carefully. True. And I lost. Damn it. This is a good argument. We weren't able to defeat it. What does that mean? There was no situation. I looked at all 8 possible situations that could occur in the world, and in no case are the premises true with a false conclusion. So this argument is valid. It is a good argument. I couldn't defeat it. Damn it. And finally, we have this monster, right? This is terrible. Look at this thing. I have taken the argument, wrote it out on a single line. I have clearly separated the premise, clearly separated the conclusion. These cases are simply a matter of staying organized. What do? I label my main connectives. There they are, right? Again, you'll draw a star over them. These conditionals will barely show up, right? But those are my main connectives, right? So I need to be careful that those are the final values I solve. So let's work in the first premise first. Oh, sorry, skipped a step. Determine the number of rows you will need. We have 3 different letters, so we will need 8 different situations, right? Let's get rid of the rows we don't need so we can have a nice clean table. Good. So I fill in next my basic sentence letter values. I use my little algorithm. I go to the letter that is last alphabetically, G, and that will alternate true, false, all the way down, alternating every row, true, false. You'll get a little quick at this as you go. Just make sure you maintain the sequence. A good test is they will always start with true, always end with false. Oh, that's annoying. My cursor's in the way. Sorry. I filled in G's, alternating every row. So now I can fill in the D's, working up my alphabet. These will alternate every 2 lines. Wherever D appears, same thing. Oops, messed up. Wherever D appears, I'm alternating in the same sequence, being very careful. I am just a monkey filling these in carefully. Now I go to A. A will alternate every 4 lines. Good. Everywhere A appears, same sequence. Sorry, cursor's in the way again. Now, I need to solve from smallest to largest scope, right? So now I will work. So now I can solve working from smallest to largest scope, so I'd be very careful. Let's start in this first premise here. Good. The smallest scope will always be inside the parentheses, and in this case, inside the parentheses is a negation that only applies to G. So I can solve that first. What do? I simply reverse the values of the sentence to its right. So I simply convert all these values to their opposites. I will use the method of crossing out the columns I no longer need. I will simply dark them in gray so that I can pay more attention to the values that are left. Now I'm inside parentheses still. I'm solving a biconditional. Repeat. Make sure. A biconditional is true when both sides are the same. So I can look down my column at a glance and simply label as true wherever both sides are the same. I see 4 cases that are the same. What does that mean? The other 4 cases are not the same, so they will be false. So I'm going to use my method again. Again, I like underlining, right? Crossing out so I can follow my order, but I will follow through on the technique I've been using, and I'm simply going to shade out the columns that are replaced. Good. So now, in parentheses, the only value left is this value under the biconditional. And now I'm ready to solve the main connective. That's all that's left. I'm comparing the value under the biconditional to the value under G, and I'm comparing in terms of AND. Repeat. An AND is only true when both sides are true. An AND is only true when both sides are true. So notice, I'm being very careful that I'm only looking at the right values, the correct ones. And so I see line 3 is both sides true, and line 7 is both sides true. I do not see any other cases, so the rest of these cases are false. Good. That is my main connective, so I circle it, in my case, label it in orange. Good. Now, look at this beast, right? I need to be very careful that I work from smallest to largest scope, right? So look, I follow my parentheses, see where they open and close. Here is the innermost parentheses, so I will start here. Good. It is a conditional. A conditional is only false when ordered true then false, so I see my 2 false cases in lines 3 and 4. What does that mean? All the other cases of this conditional will be true, so I can just fill those in quickly. Notice I have now replaced the value under A, so I can get rid of it. I have replaced the value under D, so I can neglect that as well. This is the value left for the innermost parentheses. Now, be very careful. Look at how your parentheses open and close, so I can see here is my next parentheses value. So I'm comparing the values under the conditional I just solved to the value under this A here in terms of this AND. Good? An AND is easy. An AND is only true when both sides are true. I see that in lines 1 and 2, and that's it. All the other cases of this AND will be false. Good? So again, I know this method, it is better on paper where you can underline and cross out as you go, but I now no longer need this column, so I will gray it out. I no longer need this column, so I will gray it out as well. Notice, all I have left in these parentheses is G and the values under and I'll compare in terms of this disjunction or. What are we looking for? An or is only false when both sides are false. So I will simply look for those cases, fill those in to make it easy. I see 3 false cases. All the others will be true. So that is the value of everything in parentheses. So notice, what does that mean for me? I can cross out the values I no longer need, right? I would draw a bunch of underlines under the value here if I'm working in paper. But for me, this line, this column, is all that's left of everything in parentheses. Now I go to the right side. Now notice, before I solve the main connective, I first must fill in this negations value. So I simply reverse the values of D, really easy, reverse values. What does that mean? Values under the column of D are no longer needed. I will shade those out. Look at all that's left. This is pretty easy if you're looking in the right ways. So again, I would underscore this several times if I'm working on paper, so I'm sure to only look at this. If you are this savvy, you can even write these in really dark, right? Go over them a couple times, bold them with your pencil. Make sure you're only paying attention to the two columns that are left. All the other values have been replaced. I can now solve my main connective. The main connective is a conditional. A conditional is only false when ordered true then false. I see a case like that in lines 1, in line 2, line 5, and that's it, right? If I'm looking really careful, let me double check what I've got, right? Yes, those are the only cases where true on the left, false on the right. Let me double check, triple check. Good, right? I have 3 falses under the main connective. All the others are true. Good, right? Really be careful that you're looking at the right places. Good. That is my main connective, so I circle that. That's the only value I care about now, right? I will bold it in orange. Conclusion. I must work from smallest to largest scope. That means I must solve this negation first. Simply reverse the values of D to make it negative. So I can get rid of the values under D. I hope this works and it shows up really nicely. Good. I have only my main connective left. The main connective is a conditional. A conditional is only false when ordered true then false. So I will look for my false cases. I see 2 of them. All the others will be true. Notice if you're thinking very theoretically and you're really a nerdy, smart person, right? You don't get invited to dances, but you're good at symbolic logic, right? You're a wallflower. Sorry, so there are perks. Don't worry. If you're a big nerd, you will have a happier adult life. Sure, teenage years might not have been that fun, except for Dungeons and Dragons and video games, right? But there will be a reward. Your career will be fun like mine is. Good. So I have circled the values under the main connectives, and now I'm ready to read my table. What am I looking for? I am looking for a case that proves this invalid. I want this to be invalid, right? I want true premises with a false conclusion. Now notice, if you are a nerd, there are only 2 conclusions that give me what I want. So here's my false conclusion. Do I have true premises? No, I lost. This conclusion, this argument could not be defeated. It's valid. It's a good argument. I lose, so it's valid. I hope you're doing this well. If you're good at this, you will do incredibly well. You will get some perfect scores on the final exam for this part of truth tables. All right. Thanks. Bye.